Okay, so let's take a look at a situation where the function isn't defined as an equation. It's actually, in this case, given as a table. And so again, we're working with a function notation. I believe, again, this is Appendix C for the most part. So domain, well, we're only defined for 1, 2, 3, 4, 5, 6 different x values, and they're discrete. So we're going to use discrete notation, and my domain just consists of those 6 values, -2, -1, 0, 1, 2, 3. We can predict where -3 or 4 or 8 might go, but that's not being defined, right? That's a prediction and it's a guess. I only know that -2 goes to -4, -1 goes to -2, 0 goes to 1, 1 goes to 2, 2 goes to -2, and 3 goes to 0. So these are the only x values, as far as p of x is concerned, that are creating outputs. The range, well, that's just all these outputs. So it looks like we have -4, -2, 1, 2, and it looks like, let me sneak in 0 in there. So these are the only outputs that are created from all these inputs. So your domain and your range, inputs, outputs. P of -2, well, again, we're looking at an input, x is -2, and I'm looking for the output when that happens, and that's just the y value. So I'm just going to go over here. Here's where x is equal to -2, and it looks like we have an output of -4. So P of -2 is equal to -4, and that's all there is to it. P of a half, well, if we go to our domain, right, x equals to a half is not in the domain. Again, we can probably predict it, right? A half sits between 0 and 1, and we're going from 1 to 2, so we can predict that it might be 1.5, but I don't really know for sure. A domain value is something that I know exactly where it's going and what exactly it's inputting. So this would be undefined. We don't know, right? 1/2 is not in the domain. So unfortunately, we can't actually answer that question. The next one, there's a lot going on. Hopefully in a good college algebra class, you just found out that this is slope, y2 minus y1 all over x2 minus x1. But in terms of procedure, we first have to find p of 3. Well, I'll just go to the graph, right? When x is 3, the output is 0. And then we're going to subtract whatever p of -2 is. Well, when x is -2, the output's -4. And of course, down below, this is 3 plus 2, because the subtracting of a negative is the addition of an opposite. So we get the same thing upstairs, right? When we subtract -4, we actually add 4, and what we get is 4/5. So picture-wise, if we were to graph these points, this point to this point, the slope from those 2 points would be 4/5. That's technically what's going on in a bigger position. But in terms of just the dynamics, what I'm asking you to do, that's it. Just read the graph, put things in there, do the math. P of x equals to 0. In this case, we're not given an input, we're given an output, right? Y is 0. So I basically have to figure out, right, well, when y is equal to 0, what's the corresponding x value? And it looks like it's 3. So you can write x equals 3, or you can say functionally that p of 3 is 0, right? So either answer is acceptable in my book. You're looking for an input. In this case, p of x is equal to -2. So again, y is equal to -2. Well, there's a -2 and there's a -2. So it looks like we have 2 x values, right? -1 and 2 respectively. Or functionally, you can say this, right? So when the input's -1, the output's -2. When the input's 2, the output's -2. So there's your 2 answers for that. P of x equals 4. Well, if we look again at our range, I don't see a 4 in the range. So again, we could guess, but in order to be in the domain and range, it has to be explicitly defined, or there has to be a way that I can get an output of 4. So I don't see it in the range, so therefore, just like in an earlier thing, this is undefined, right? I can't find it. So that's basically how you use function notation for a situation when the function is given as a table. All right, turning the page or looking at another example. Let me kind of clear that out. What happens when the function is given as a graph, right? What do we do in that situation, right? So that's problem number 3 here. So in problem number 3, right, I'm given this graph, right? This is a picture of g of x, and I'm being asked questions on it. Well, the first one, again, is the domain. Well, again, I'm looking for x value. So it looks like starting at -6 and including it, and going all the way to 4, not including it, right? There are outputs associated with those x values. So right now it looks like we're starting from -6 and going all the way to 4 and using parentheses. So a bracket is closed and parentheses is open. However, right, what happens is we have what is called a piecewise function. At 4, we're no longer defined for this curvy guy, we're defined for this line. So it actually looks like we pick up the story, right, and 4 to infinity. Technically speaking, since this would be one way to write it, because I broke it up in pieces, but you could also say from 6 to infinity, because 4 actually is included in the domain. It's just there's a kind of a ripping apart. The range, we're now looking for y values, right? And so in terms of y, we can see at the bottom it assumes the value of -5, right? And it comes all the way up and assumes the value of 1. But there is truly a gap in the range, right? Because it picks up at 4 and goes up again. So our range truly has 2 intervals. It looks like it's from, let me make sure I got that right, 1, 2, 3, 4, yeah, -5 to 1 union, and it looks like it starts again at what, 4 to infinity. So there would be my domain and range, the inputs and the outputs for that function g. G of 0, well, we're looking for when x is equal to 0, what's the y value? So I'm just going to go where x equals to 0, and it looks like the corresponding y value is -5. G of 4, well, in this case, x is equal to 4, so we're trying to find the y value. So when x is equal to 4, you got to be careful, right? That's open, so it's not equal to that. It's right here, it's closed. So G of 4 for this graph is actually equal to 4 because of the openness of the situation. G of -7, well, in this case, again, x is equal to -7, and we're trying to find the y. So when x is equal to -7, I can see that there's no graph associated with it. Since there's no graph associated with it, that means it's not part of the graph. It's not part of the relationship. It's not in the domain. So this is undefined. Okay, G of 6 minus G of -1. Well, again, we're looking at y values for specific x values. So when I'm equal to 6, it looks like the corresponding output is 6. When I'm -1, it looks like the corresponding output is about -4. And down below we have 6 plus 1. So we have 6 plus 4 over 6 plus 1. What we're looking at is 10 over 7. And again, just to kind of look ahead, if we looked at the slope of that line between those 2 points, that slope has a 10 over 7. That's essentially what that crazy situation represents. Moving forward, g of x equals 0. Things are a little different now because I'm giving you a y value. Y is 0, we got to find the x. So when y is equal to 0, right, it looks like we have an x value here, an x value there, and an x value there. So it looks like -5, -3, and +3 are our answers for those inputs. So there's the inputs that create an output of 0. G of x equals to -2. Well, again, y is equal to -2, and we're trying to find the x. So when y is equal to -2, it looks like I have 2 inputs, -2 and 2 respectively, as I read my graph. Y equal to 3, what's my x value? Well, when here y equals to 3, we see that there's no function, there's no graph associated with y equals to 3. So this means, again, it's not in the range, which means that this is undefined. Okay, so in these last 2 videos, we basically took a look at function notation, graphs, tables, equations. We threw in graphing, we threw in slope, so there's a lot of ideas that came in through, but predominantly we're looking at Appendix C to practice all your notation there. All right, so let me stop here and cut away, and we'll do another video because this is already almost 10 minutes long. So more coming up.